Okay, pause and copy this down. Okie dokie. Ignore ignore this stuff for now. That's kind of the answer that we'll use later. What we're looking for is an estimate of this area. It's the area under the curve from 0 to 1. So we want to estimate that area. Now, we're going to use 4 rectangles, equal width. So what that means is we're going to take our interval, this interval from 0 to 1, and we're going to break it up. We're going to break it up into 4 equal pieces. So we'll break it in 4 equal pieces like that. So we'll put a break at 0.25, 0.5, 0.75, and at 1. Now, above every subinterval, so this is a subinterval from 0.75 to 1. Every subinterval, we're going to draw a rectangle. So if I look at this subinterval, I will follow the instruction to use a right endpoint. So I will use this endpoint and go up to the function and then stop. And that will be the height of the rectangle that is drawn. Oops. That is drawn over that subinterval. So again, I chose here's my subinterval. I chose the right endpoint as instructed. And I use the right endpoint to determine the height of the rectangle. I continue this for the other subintervals. So I get a rectangle in each case. And then over here, see if I can draw this small rectangle down here. Something like this. Okay, so the idea is that sum of rectangle areas is approximately equal to area under curve. Okay, this is not a very good approximation, but it's a starting point. So this symbol means approximately equal. Okay, let's find this approximation. Let's go with blue, why not? Okay, so the approximation is, well, I'm going to go left to right. What will I do? I'm going to go, base times height for each rectangle, starting with the first one. So the base is always 1. And then the height of the first rectangle, well, it's you take your function and then you plug in this x value here, this x value here, f at 0.25. Plus second rectangle. Base is, oops, no, base is not 1. The base is 0.25, right? So for the first rectangle, let's go back here. The base is 0.25 and the height is this value here. Second rectangle, base is 0.25 again. Height is f, width, now it's 0.5. You plug in 0.5 into your function, right? Third rectangle, 0.25 times f of 0.75 plus last rectangle, 0.25 for the base, and then the height is f with 1 plugged in. So what can we do here? Well, we can clean this up by factoring out 0.25. And we get f of 0.25 plus f of 0.5 plus f of 0.75 plus f of 1. Now let's work this out. What is the function? F of x is x squared. That's our function, 0.25. We get 0.25 squared plus 0.5 squared plus 0.75 squared plus 1 squared. Now you have a calculator, you can do this quickly. I'm going to do it rather slowly. This is a quarter. Oh, what should I do? Oh, whatever, I'll just go 0.625, 0.25 plus, what is 75 squared? That's a good question. 3/4 times 3/4, 9/16. Whatever that happens to be, I don't know. I'll just write out 9/16 for now. At some point, you will break out your calculator and you will work this out. And hopefully I didn't make a mistake anywhere. I should get 15/32. Well, just to be careful, let's work this out. So what is, of course, is 1/16? No. This can't be right. That's not right. I should have 0.0625. So switching to fractions, because everyone prefers fractions, right? Plus 16/16. What do you get? 1/4 times 1 plus 4 plus 9 plus 16 all over 16 is what? 5, 14, 30. 30 over 4 times 16. How does that look? Oh, I don't know. 15. 15/32. There we go. That is what I want. Okay. Exercise. Do the same thing. But use left endpoints. Okay, so same question. So you want to approximate the area under this function from 0 to 1. You want to use 4 rectangles of equal width But now you're going to use left endpoints to determine the heights of the rectangles. So your rectangles, you should draw a picture. Your picture is going to look different. You're going to have the same subintervals, but the heights of the rectangles will be determined by the left endpoints. So pause the video, or actually we'll take up the answer in the next video.